All right, so let's start a new chapter, chapter 3. Here you are going to learn about kinematics in 2 dimension and projectile motion, which is basically application of kinematics in 2 dimension. Okay, so in last chapter you learn about kinematics in 1 dimension. That means our motion was either along the x-axis or along the y-axis. So in this chapter, we are going to basically combine the motion in x direction and motion in y direction together. Okay, so before we learn about that, first let me briefly review the scalar and vector and the vectors in 1 dimension. Okay, and then in the next slide we are going to learn how to combine vectors in 2 dimension. Okay, so what is vector? A vector has magnitude as well as direction. Okay, so what it means? It means to describe a vector we need both magnitude and direction. Okay, so some of the examples are displacement, which we already learned, and then velocity we already learned, force, momentum you will be learning later. Okay, position is another vector quantity. On the other hand, to describe scalar we just need magnitude. Okay, so it has only magnitude. Some of the quantities, scalar quantities, are time, that we already learned. You will be learning mass and temperature later in this course. Okay, all right, so let's look at this picture here. So here, this is a picture taken in New York City. Although it is taken in New York City, it's a typical city picture. Okay, so here you know that here you see that a car, let's say we have a car and it is coming in this direction. Okay, now if it's just going in this direction, okay, then it's okay to only use 1-dimensional motion. Okay, but let's say this is going in this direction and then changes direction and it goes in this direction. Okay, or some other direction. Okay, so now you see that if we want to deal this kind of situation, okay, this direction and this direction, so 1-dimensional motion cannot explain all these. Okay, so we need to understand how 2-dimensional motion works. Okay, so in this chapter you are going to learn about that. Okay, all right. So before we do that, before we know, before we learn how to add 2-dimensional vector, vector in 2 dimension, let's briefly review how we can add 2 vectors in 1 dimension. Okay, let's say, let's talk about the displacement, right? So displacement is a vector, and if you remember, displacement is the change in position, right? In last chapter you learned about displacement, and if you remember, the definition of displacement was something like this: delta x equal to x2 minus x1. So the final position minus initial position. Okay, so delta of any quantity means final quantity minus initial quantity. So delta x means change in position is equal to final minus initial positions. Okay, so let's say that I started from the origin at this point and I walk 8 kilometers. Okay, so this is, for this part, this is my initial position, this is my final position. So the displacement here is 8 kilometers east. Okay, because I am walking to the east. Okay, and then I restart from this position. So now this is my initial position, and then I stop here after I walk 6 kilometers. Okay, so this is my initial, this is my final in this case. So my the displacement for the second case, okay, second time, it is again 6 kilometers east. Okay, so the total displacement here, or the sum of these 2 vectors, is basically 8 kilometers plus 6 kilometers. Both are in the east direction. So the total resultant, or the sum of these 2 vectors, is 14 kilometers. 8 plus 6 is 14, and because both the direction of both displacement is east, so the resultant displacement, or the sum of the displacements direction, is also east. Okay, so you see that we can just add them together. Okay, so if both are in the same direction, okay, both vectors are in the same direction, then we can just add them together to get their sum, or um, to get the resultant vector. Okay, similarly, if we start from origin and walk 8 kilometers, so this is again 8 kilometer east, and if I change the direction, instead of walking in this direction, let's say I change my direction and I walk 6 kilometer in the west, so my direction is west for the second time. Okay, so the displacement for the second part is 6 kilometer west. Okay, now if I want to know what is the resultant displacement, or sum of these two vectors, so this is one vector, this is another vector, so if I want to know what is the displacement, the sum of these two vector, then what I have to do, I have to write something like this: plus 8 kilometer because it is to the east, minus 6 kilometer because it is to the west. So if I add them together, I get plus 2 kilometer. Okay, and plus 2 kilometer tells me that the direction of the resultant vector, or the sum of these two displacement, is to the east. And here you see that the direction of the resultant, or the sum of these two vector, is to the east, but the magnitude is 2 kilometer. So in this case, you basically subtract these. Okay, so if two vectors direction are same, then we add. If two vectors directions are opposite of each other, okay, then we subtract. Okay, but life is not this simple. Okay, so in the picture, in the city picture, you see that I mean, the car is not going just in this direction or in this direction. Okay, car goes in this direction and then change to this, right, or these. Okay, so if we have some situation, something like this, how to deal with um, um, how to deal with these. Okay, so let's try to understand this. Okay, okay, so how to add two vectors in two dimension. Okay, so we'll be learning two different method. One is graphical method, another is analytical method. And analytical method is very important because in most of the problem we will be using analytical method, but graphical method is also important because graphical method will tell you the graphical picture of the vector addition. So if you don't have any graphical picture in your mind, it will be very difficult to use the analytical method. So both are important, although most of the time we use analytical method for problem solving, but if you do not understand the graphical method, you basically, I mean, it will be very difficult to do the analytical method. Okay, all right, so before all that, let me tell you that from now on, when we write a vector, we use an arrow on top of it. For example, now if the displacement, if we want to write the displacement, we have to draw an arrow on top of it. You have to draw an arrow on top of a velocity vector because velocity is a vector. Okay, in next chapter you will be learning about force. So on top of force we have to draw an arrow. So this arrow tells us that this quantity has some direction. Okay, so to differentiate between scalar quantity and vector quantity, on top of vector quantity we now use arrow. Okay, so remember that from now on, whenever we have a vector quantity, we will be using an arrow on top of it. Okay, all right, so let's start with a very simple problem. So let's say now now the displacement is 10 kilometer east. So the first displacement d1 is this 10 kilometer east, and d2 is this one 4 kilometer north. Okay, so this the length of d2 is 4 kilometers. So you see that, okay, or approximately 4 kilometer. Okay, now how to add them? Okay, so this is our initial position and this is final position. So this line basically tells about the resultant displacement. The sum of these two vectors will be this line. Okay, but how to know this is the line? Okay, to understand this, the graphical method, the first method we are going to use, and it has also another name, we call it tail to tip method. Okay, so let's first learn about the tail to tip method. Okay, yeah, so before I go there, so let me tell you that so here I started from this vector and then add this vector, but it does not matter if you start first from this vector and then draw the second vector. Okay, in both cases the resultant will be same. What I mean is d1 plus d2 is basically equal to d2 plus d1. Okay, so when you draw a vector, I mean when you want to add two vectors or two or more vectors, it does not matter the order. Okay, you can exchange the order. So either you can first start with d1 and then d2, or you can start with d2 and d1. In both cases you will get the same value. Okay, so here you see this one, we first draw the d1 and then d2, and here we first draw the d2 and then d1, but in both cases the resultant is this one. Okay, so we are going to learn how to draw this resultant. Okay, all right, the method we need now is called the tail to tip method. Okay, so tail to tip method tells us that if we have one or more vectors, I mean more than one vectors, then we first draw one vector. Okay, when we want to know what is the resultant of these vectors, so we first draw the first vector, and from the top, from the tip, I mean tip means the head of the first vector, we draw the second vector. Okay, and then from the tail of the first vector, okay, we draw another line to the tip of the last vector. Okay, so from the tail of the first vector to the tip of the last vector, that is the tail to tip method. And the tail to tip method tells us that the tail to tip, tail of the first vector to the tip of the second vector, is the resultant. Okay, resultant or sum of these two vectors. Okay, all right. So here you can draw, you can add as many vectors you want. Okay, so we are going to see that. Okay, so here, so in the last problem we basically add two simple vectors, one along the east, one along the north. Okay, now we can add vectors in random direction. For example, here in this problem we have v1, v2, v3. So v1 is some random direction, v2 it looks like along the south, and v3 it looks like along the west. Okay, but it doesn't matter in which direction they are. I mean what are the direction of the individual vectors, the rule is same. So what is the rule? So we first draw the first vector. Okay, so you can choose any of them, either v1 or v2 or v3 as your first vector. Okay, it doesn't matter. Okay, so you first choose the first vector. Okay, so let me choose the v1 as our first vector, and then from the head of the first vector we draw the second vector. Okay, so this is the head. Okay, this is the head and this is v2, right? So from the head I draw the second vector, and it should be this one. So this is now v2. So v1 is this one, v2 is this one. So now we have another vector v3. Okay, so how to add v3 in this picture? From the head of the v2 I have to add v3. Okay, so this is v3. So make sure the direction of the vectors are the same. Okay, so here you see v1 is this one and v2 is downward, so I keep the direction same, and v3 is west, along the west, so I also keep the same direction for v3. So once you have that, then the resultant of this 3 vector will be a line that starts from the tail of the first vector. So this is the tail of the first vector to the tip of the last vector. So this is the resultant. Okay, so this is how we add vectors. Okay, so in this method we can add as many vector we want. Okay, so this method we are going to use to have some idea how the in which direction graphically the resultant vector will be. Okay, and then once we know that, then we will be using the analytical method. Okay, now let me show some simulation. So here I have a simulation. Let me go to the simulation. So here is the simulation, and here I am going to show you how to add some vectors. Okay. Okay. So here, so let me bring first vector. So let's say we have this vector, and I want to add this vector with another vector. So let me bring another vector. So here, when you add in this simulation, if you want to add a blue, so blue can add only with blue. Okay, so you cannot add blue and brown together. Okay, all right, so let's say we have this vector and this vector. Now I want to use, okay, so both are same, so let me change it. Okay, so let's say this vector is this, so I want to add these 2 vector. Okay, so this is one vector and this is another vector. So these 2 vector I want to add, and I want to use the tail to tip method. Okay, so to use the tail to tip method, so you first draw this vector. Okay, and then from the head of the first vector I draw the second vector. So here this is the second vector, right? Now what would be the sum of them? Sum of them will be from this to this. Okay, so this should be the sum, the yellow line. So here if I click here to sum, blue sum, okay, so you will see that it is exactly the same thing. Okay, so you see that the yellow line and the blue line matches each other. I mean the dark blue line. Okay, so that's how tail to tip method basically works. Okay, so here I use 2 vector. I can use more than 2 vector. Okay, so let me show you. So let's say we have another vector. Okay, now, okay, so let me, okay, so you see that first vector, from the head of the first vector I draw the second vector, from the head of the second vector I draw the third vector. Okay, then the resultant, the sum of these 3 vector will be this line, right, from the tail of the first vector to the tip of the second vector, to the head or the tip of the last vector. Okay, so here as we have 3 vectors, so from the tail of the first vector to the head of the third vector, and now you see that the sum, this sum basically tells the same thing what I draw earlier. Okay, so this is tail to tip method. All right. All right, so there is another method, graphical method we also use. We call it parallelogram method. Okay, so although parallelogram method we don't use much, but sometimes this method is also useful. Okay, so both tail to tip method and parallelogram method are basically used to have a graphical picture in our mind. Okay, and then once we have the graphical picture, it will be very easy to solve the analytical method that we are going to learn in the next slide. Okay, so what is the parallelogram method? Parallelogram method is very similar to tail to tip method. Okay, but here we use, okay, so here you see that if we have two vector, if we have these two vector, we use the tail to tip method and we get something like this. Now in parallelogram method, instead of using the second vector, I mean, instead of drawing the second vector from the head of the first vector, we draw all the vectors from the same origin. So this is the same origin. Okay, so you see v1 is this one and v2 is this one. Okay, so v1 and v2 from the same origin. Once we have that, we draw a parallelogram. So here you see that we draw a parallelogram and then we draw a diagonal. Okay, so diagonal also starts from the same origin. Okay, so you see that. Okay, so this diagonal is basically the diagonal that starts from the same origin is the resultant or the sum of the two vectors. Okay, it's very similar to the tail to tip method. In tail to tip method, we draw the first vector first, and then from the head of the first vector we draw the second vector, and the resultant is the resultant starts from the tail of the first vector to the head of the last vector. Okay, so here you see that this is the resultant or the sum of the two vectors. In the parallelogram method, we draw both vectors from the same origin. So here you see that v1, v2 drawn from this point, and then we draw a parallelogram. Okay, we draw a rectangle. Okay, and then we draw a diagonal from the same origin. Okay, from the same origin. So the diagonal that drawn from the same origin is the resultant, and you see that this resultant and this resultant is basically the same. Okay, all right, so that's how tail to tip method and parallelogram method works. Okay, okay, now how to subtract and how to multiply a vector. Okay, so here we basically learn how to multiply a vector by a scalar number and how to subtract. Okay, we already know how to add two vectors, right? Subtraction, if you understand how to add two vectors or two or more vectors, subtraction is basically similar. Okay, simple. Okay, now to understand the subtraction, the first thing you need to understand that if we have a vector something like this, okay, the negative of this vector has the same length, okay, same magnitude, but the direction will be opposite. So you see that v is this and negative v is this. Okay, so the length of these two vectors are the same, but the direction are opposite. So when we have a negative sign, okay, then the direction will be opposite. Okay, so let's say if we have a vector something like this, let me call it a. Okay, now minus a will be the same length of this, but the direction will be opposite. Okay, so because the direction here is this, for minus a negative, the direction will be this one. This is basically minus a. Okay, so once you understand this, then subtracting a vector is not a big deal. Okay, so let's see how to do that. Okay, so let's say we want to subtract v1 from v2. So v1 is this one, sorry, v2 is this one, and v1 is this one, and we want to subtract v1 from v2. So negative v1 is this one, right? So if I want is positive v1, okay, if I want that is equal to positive v1, then what I have to do is plus negative to positive, and then the length of the vector should be equal, but the direction now will be opposite. Okay, so this is v1, this is positive v1. So this one negative v1, here we have positive v1. Okay, now what we have here, we have a vector, we have a we have a vector here, so that is v2. We have a vector here, that is v2, and then v1 is this, right? V1's direction is this. So we add this together, so this is v2 and this is v1. Okay, now from the tail to the first vector to the tip to the second vector is the resultant. So this is the resultant. Okay, so here you see it's exactly the same thing. Okay, so when you have to subtract a vector, you can do little trick, changing the direction, okay, and then add them. Okay, so do this small trick, and then it's basically adding two vectors. Okay, all right. The next thing is how to multiply two vectors. Multiplying two vectors is easy. I mean, multiplying here, we are multiplying a vector by a scalar quantity. Okay, so if I want to multiply this vector by 1.5, so the length will be higher than this one. So length of this arrow is about is exactly equal to 1.5 times of the first vector of v. The direction should be the same. Okay, so you see that when you multiply this, it will be longer. Okay, so it is longer and the direction is the same. Okay, now if I want to know what is minus v will be the same length as v, but now here we have -2, so it will be twice longer than the first v. Okay, so this is minus twice v. Okay, negative sign, that's why the direction is opposite, and 2 times v means the length of this vector is twice the length of this vector. Okay, very simple. All right, so if you understand so far, the next thing is analytical method. Okay, so analytical method is very important to understand. Okay, so what is the analytical method? So any vector, it says that any vector can be expressed as the sum of two vectors which are called its component. Okay, so if we have a vector, we can resolve this vector into its component. Okay, if we have a vector in any random direction, okay, we can resolve this vector into its x component. Normally it has two components, one along the x-axis and another along the y-axis. Okay, so let's say we have this vector. Okay, so this is the vector which is the sum of its component vector. Okay, so what it means, if we have a vector, we can break it or we can resolve it. I mean, break and resolve here is the same thing, into its component. Okay, or if we have two components of a vector, we can add them together to get that vector. Okay, so how it works mathematically, let me show it. Okay, and to understand this, you need to understand some trigonometry. Okay, so if you forget the trigonometry, it's okay, just review this lecture. Okay, all right, so let's say we have this vector, okay, a, okay, that makes an angle theta with positive x-axis. So this is the vector. Okay, this makes an angle theta, here theta equal to 30 degree with this line. Okay, now here we can resolve this vector into its component. Okay, so component means, let me call it ax, the x component, and let me call ay its y component. Okay, so the component vector will be, so this will be ax and this will be, or this will be ay. Okay, so this and this the same thing. Okay, when two vectors are parallel, okay, they are basically the same thing. Okay, if two vectors are parallel and equal length, you can treat them treat these two vector as the same vector. Okay, so because here this vector and this vector looks like the same length and the same direction, so they are the same. Okay, so if we have a vector, we can break it into its component, one along the x-axis, one along the y-axis. Okay, so if we then add them, a y and ax, we get back a. Okay, so what it means that if you have a vector and if we know the angle of this vector, okay, then we can break this vector into its component. On the other hand, if we know the component, we can get back the vector and the angle. Okay, and to do all this, we basically need trigonometry. Okay, now in trigonometry, you probably already remember, in trigonometry, okay, sine theta, so if we have a right triangle, something like this, okay, something like this, I mean, if you have a right triangle, something like this, right triangle means one of the angle is 90 degree. Okay, so if you have a right triangle, then sine theta, so if this is theta, okay, sine theta is defined as this: opposite length and hypotenuse. So this is opposite and this is hypotenuse, so opposite by hypotenuse. So opposite here is vy because it is along the y direction, and hypotenuse is v. So sine theta is opposite by hypotenuse. Cosine theta is adjacent by hypotenuse. So cosine theta is adjacent is this one, vx, and hypotenuse is this. So cosine theta is vx over v, and tan theta is opposite by adjacent. So vy by vx. Okay, so this part of the trigonometry we need to understand when you want to break a vector or break a vector into its x component and y component, or from the x and y component to get back the vector. Okay, so all right, so if we understand these, the next part is to write the component vector. So let's say we have this vector. Okay, let's say we have this vector. Now you can draw graphically. Okay, so this is the x component and this is the y component. Okay, now you see that this is the x component, first vector. From the head of the first vector you draw the second vector, and then you see that this is just the from the tail of the first vector to the tip of the second vector. Okay, so you see that once you know the tail to tip method, you can form these. Okay, and then do the math. Okay, so now I'm going to, so once you have a clear picture of this configuration, okay, how to break a vector, then we can write the mathematical equation. That will be easy. Okay, of course you need to know the trigonometric part. All right, so I believe you have a clear picture now. Okay, so the ax will be, so here, sorry, here this is a v, so vx will be v, so vx is basically this one, right? Adjacent part, right? So vx adjacent is related to cosine theta, so vx will be cosine theta. So you can see that here, vx equal to v cosine theta. Okay, and this is vy. Vy is opposite to theta, so vy is v sine theta. Okay, also you can see that from this equation. Okay, so once you have a vector, you can break it into its component by using this trigonometry. And if it is adjacent, for adjacent we use the cosine theta. If it is also opposite, we use sine theta. Okay, remember this trick. Now if we know this vector, I mean this component and this component, we can get back to the original vector by using Pythagorean theorem. Okay, so how? Because you see that this is a triangle, right triangle, right? Pythagorean theorem tells us that if you know this vector, the length, if you know this length, then this length will be this v square equal to vx square plus vy square. So v, the length of this vector, is basically vx square plus vy square. Okay, very simple. So once you have the component, you can get back to the original vector by using the Pythagorean theorem, and this is that. Okay, how about this angle? Okay, this angle you can get back by using this equation. Okay, tan theta is equal to vy over vx. So if you know the component, you can get back the theta by using this equation. All right, very good. Now here I already, I mean, all this information, you can see this in this slide. Okay, and if it is difficult to understand, email me, I can discuss it again. Okay, all right, so here you can see that. So if we have a vector, v, and if you know the theta, then we can write vx and vy. On the other hand, if we know the vx and vy, we can get back v from the Pythagorean theorem and theta from tan theta equation. Okay, so yeah, so the equation was tan theta over equal to vy vx, but we basically want to know theta, not tan theta. So theta is equal to tan inverse vy over vx. Okay, and here you have to be careful when you calculate the theta. You have to be careful, make sure you change the calculator mode in degrees. Okay, sometimes students forget to do that, so then what they calculate is the angle in radian. Okay, so that is not what we want here. We want the angle in degrees. Okay, so when you calculate theta, make sure you change your calculator mode in degree. Okay, all right, so now you know how to break a vector, or if you have the components of a vector, you know how to add them to get back the vectors. Okay, now the goal of all this is not to just break a vector or add the component to get the original vector, but also how to add two vectors together, to separate two different vectors together. Okay, so here I'm going to show it. Okay, so let's say we have this vector v1. Okay, and we have this vector v2, and I want to know what is the resultant vector of these two vectors. What is the sum of these two vectors? Okay, so the first thing we have to do is to get a graphical picture, draw them by using tail to tip method. So if we use the tail to tip method, so this is the first vector, this is the second vector, then the tail to tip method tells us that this is the resultant vector. Okay, so this is the graphical representation. Now now how to use the analytical method here? Okay, to use the analytical method, the first thing you have to do is you have to break v1 into its component and v2 into its component. Okay, so the first thing here we have to do after we have a graphical picture in our mind, okay, then the next thing we have to do is break the vectors into their components. Okay, so let's say v1. Okay, so this is v1, and let's say this makes an angle theta 1 with the horizontal. Okay, so let's say this is theta 1. Okay, so theta 1 is basically the angle that this vector v1 makes with the horizontal. Okay, so horizontal means it's with the x-axis. Okay, then if I break it, okay, so this will be the v1x and this will be the v1y, and v1x will be v1 cosine theta 1, right? And v1y will be, because it is opposite, it will be v1 sine theta 1, right? So that we already learned. So when we have a vector, we can break them, we can resolve them into its components by using these two equations, right? Now what about the v2? So this is v2, and v2, let's say, makes an angle theta 2 with the horizontal. So this is the horizontal. So horizontal means horizontal line means it is the x-axis. Okay, so it makes an angle theta 2 with the horizontal. So that means v2x is this one. Okay, and v2y is basically this one. Okay, so v2x will be v2 cosine theta 2, and v2y will be v2 sine theta 2. Okay, all right. So once we have the components for these two vectors, then the rest of the thing are very simple. Okay, the rest of the thing are very simple. So we are going to follow the rules here I wrote down. Okay, so let me erase this because it's already there. Okay, okay, so once we break this vector into their component, okay, so okay, so let me read this again. So draw a diagram, add the vectors graphically. So yeah, tail to tip method normally we use. Choose x and y axis. Yeah, so normally we use our usual convention as x and y axes, and then resolve each vector into their x and y components that we just did. Okay, and then okay, so calculate each components using sine and cosine. So yeah, when you are given the value, you should basically plug the values to get the number. Okay, the next thing is the x component should be added together. So here you see that I added x of 1 and x of 2 to get the resultant x. Okay, I add the y of 1 and y of 2 to get the resultant y. Okay, so when we have, so here I wrote down that v1x equal to v1 cosine theta, v2x equal to v2 cosine theta 1 theta 2. So you have to add these together. Okay, similarly for v1y and v2y. Okay, so this is basically vrx. Vrx means the x component for the resultant vector. Okay, and vry is the y component of the resultant vector. Okay, so once you have vrx and vry, then you use this component to get back the vector, right? You already know how to do that. Okay, so you just use the Pythagorean theorem to get the vector v. Okay, the resultant vector v or vr, and theta is from this equation, theta equal to tan inverse ry divided by rx. I mean vry divided by vrx. Okay, make sure when you do this operation, make sure the calculator mode is in degree. Okay, So that's how you do, I mean, you add two vectors in analytical method. Okay, so we will do some problem in the problem solving class. Okay, so let's see. So I'm going to stop here because the next topic is little bit different. Okay, so try to understand these first. Okay, so to understand the projectile motion, we need to understand basically the kinematic equation that I believe you already have a good understanding from the chapter 2. Now you have to have good understanding to proceed for the next topic, and next topic is projectile motion. So I want you to go through this lecture and try to understand what I just taught. Okay, so here I taught how to add vectors in different method. Okay, graphical method, and we learned two graphical method. One is tail to tip method, and another is parallelogram method, and then analytical method. So analytical method is important as most of the time we are going to use this to solve problem, but that doesn't mean that we should not learn graphical method, because graphical method is important to have a graphical picture. So whenever you solve a problem using analytical method, the first thing we have to do is draw the vectors, okay, and then add them to understand the graphical representation, okay, how they add. Okay, so once we have, then we use the analytical method to add them together. Okay, so to understand the analytical method, what we did is first we break a vector into its components, and then we use the trigonometry to calculate the, I mean, to have some mathematical expression for the components. And we see that we can write down the equation for the component from the vector and the angle theta. And once we know the component, okay, we can also get back to the vector by using the Pythagorean theorem and tan theta equation. Okay, all right, so that's it for this lecture. We are going to learn projectile motion in next class.